Tonight you are about to embark on one of the most profound journeys your mind can take. A gentle exploration into the deepest mystery of existence itself. What came before the Big Bang? What existed before time learned to flow and space learned to expand? These are questions that have captivated humanity's greatest thinkers, and tonight they become your peaceful companions as you drift towards sleep. You are not just a casual observer of this cosmic story, you are its most recent chapter, carrying within your very atoms the same stardust that emerged from that primordial moment of creation. From where you rest now, comfortable, safe, and ready to let your consciousness wander, you will travel to places that exist beyond the familiar boundaries of reality. You will visit the edge of everything, where universes are born from quantum whispers, where time itself once slept in an eternal now, and where the very fabric of existence first learned to dream. This is not a journey through space, but through the deepest layers of cosmic mystery where science meets wonder and your peaceful mind becomes the perfect vessel for exploring the impossible. Close your eyes and imagine standing at the edge of a vast ocean, but this is not water stretching before you. It is the edge of everything you have ever known, everything that has ever been, and everything that could ever be. Tonight your consciousness becomes a gentle explorer, ready to venture beyond the familiar boundaries of existence itself. You are about to journey to a place that exists before places existed, time that came before time learned to flow. This is the edge of everything, the mysterious boundary where our universe touches something far more profound and unknowable. Here at this cosmic shoreline, the waves of reality lap against the shores of pure possibility. Take a deep breath and feel yourself settling into this moment. Your body rests comfortably while your mind prepares to wander through territories that even the most brilliant scientists can only glimpse through mathematics and imagination. You are safe here, held by the same forces that will guide you through this exploration of the deepest mysteries. Before our universe began its magnificent dance of stars and galaxies, before the first atoms learned to join hands and create the elements that would eventually become your beating heart, there was something else. Not nothing, never nothing, but something so fundamentally different from our reality that we struggle to find words gentle enough to describe it. Imagine trying to explain the concept of color to someone who has never seen it. How would you describe the warmth of red or the coolness of blue? This is the challenge we face when we try to understand what came before the Big Bang. We are like beings who have only ever known light, trying to understand a realm where light itself had not yet learned to exist. Scientists call this the initial singularity, but let that phrase wash over you like a gentle tide. A singularity is not a place in the way you understand places. It is not a thing in the way you understand things. It is more like the pause between one breath and the next, stretched into an impossible moment that contains everything that will ever be. Picture yourself holding a seed in your palm. Within that tiny shell lies the entire future of a mighty oak tree. Every leaf, every branch, every ring of growth that will mark the passing years. The singularity was like that seed, infinitely more mysterious. It held not just one tree, but every tree, every forest, every breath of wind that would ever stir their leaves. But here is where our journey becomes even more wondrous. Many scientists now believe that even this singularity, this cosmic seed of everything, might not have been the true beginning. Like layers of an onion, each answer we discover reveals another question beneath, and each explanation opens the door to deeper mysteries. You see, the mathematics that describe our universe begin to whisper strange stories when we trace them backward to that moment of beginning. They suggest that time itself might not have started with the Big Bang, but rather that time might have existed in a completely different form, perhaps flowing backwards, perhaps flowing in all directions at once, perhaps not flowing at all, but existing as a vast eternal now. Think of how you experience time in your dreams. Sometimes you're a child again, sometimes you're older, sometimes you exist in multiple moments simultaneously. Perhaps before the Big Bang, time existed in this dreamlike state, holding all possibilities in a gentle embrace, before choosing to unfold into the linear sequence of moments that allows you to experience this very instant. The edge of everything is not a wall or a boundary in the way you might imagine. It is more like the surface of a deep, still pond that reflects not just what is above it, but what could be. When you look into this cosmic mirror, you see not just the universe that came to be, but the infinite universes that might have been, each one a different song that the same cosmic music could have chosen to sing. Some physicists speak of the multiverse, an infinite garden where universes bloom like flowers, each one unique, each one exploring different possibilities of existence. If this is true, then our universe is just one note in a symphony of realities, each one precious, each one necessary to complete the cosmic composition. But even the multiverse, vast as it might be, rests on something deeper. At the very foundation of reality, in the spaces between the spaces, there is a field of pure potential that physicists call the quantum vacuum. This is not empty space, it is the fertile darkness from which all things emerge, like silence that holds within it every song that could ever be sung. As you rest here at the edge of everything, you become part of this mystery. Your consciousness, your ability to wonder and dream, is itself one of the universe's ways of exploring its own origins. You are not separate from this cosmic story. You are its voice, its eyes, its heart, trying to understand its own beginning. The atoms that make up your body were forged in the hearts of ancient stars, but even those atoms are newcomers to the cosmic story. Before atoms, before particles, before the very concepts of matter and energy as we understand them, there was something else. A presence, a potential, a cosmic breath waiting to be exhaled into existence. Settle deeper into your comfortable rest and let your mind drift toward a profound mystery. You have travelled to the edge of everything, and now you discover that what lies beyond is not the empty void you might have imagined. Instead, you find yourself contemplating something far more wondrous. A space that appears empty but pulses with infinite potential, like a cosmic heart beating in the darkness before light was born. This is the quantum vacuum, though the word vacuum misleads us gently. When you think of a vacuum, you might imagine the space inside a glass bell jar after all the air has been pumped out. A perfect emptiness, a true nothing. But the quantum vacuum is nothing like this earthly emptiness. It is more like a vast ocean that appears calm on the surface while teeming with invisible life beneath. Imagine standing beside a perfectly still lake at twilight. The water looks smooth as glass, reflecting the first stars of evening. But if you could see with different, the lake would shimmer with countless tiny ripples, each one appearing and disappearing in the blink of an eye, each one a whisper of possibility becoming real for the briefest moment before dissolving back into potential. This is what physicists call quantum foam, and it fills every corner of what we think of as empty space. Even now, as you rest in the darkness of your room, this invisible dance surrounds you. Virtual particles pop into existence like soap bubbles forming in cosmic champagne, living for spans of time so brief that they exist in the spaces between our thoughts, in the pauses between heartbeats, in the silence between words. These are not the particles you know from your everyday world. They are quantum ghosts, born from the uncertainty principle of one of the most beautiful and mysterious laws of nature. This principle tells us that the universe itself is restless, unable to remain perfectly still, perfectly empty, perfectly certain. There is always a cosmic fidgeting, a gentle trembling at the foundation of reality. Think of how you might feel if you tried to remain perfectly motionless for hours. Your body would begin to ache, your muscles would twitch, your mind would wander. The universe experiences something similar at its deepest level. It cannot hold perfect stillness, perfect emptiness. Energy must fluctuate, particles must dance in and out of existence, and the void must remain forever filled with the possibility of becoming something more. In this quantum foam, pairs of particles are born together like cosmic twins, one particle and its antimatter partner, bound by the laws of physics in an eternal dance. They appear together, spiral around each other for their brief lifetime, then reunite and annihilate, returning their borrowed energy to the vacuum from which they came. It is like watching stars being born and dying in fast forward, each lifetime measured in units of time so small that billions of these cosmic lifetimes pass in the time it takes light to travel the width of a single atom. But here lies the profound mystery that connects to our journey toward the beginning of everything. Some scientists believe that our entire universe might have begun as just such a quantum fluctuation, a bubble of possibility that, instead of disappearing back into the void, found a way to grow, to expand, to become the vast cosmos that now holds your beating heart and wondering mind. Picture a soap bubble forming on the surface of that cosmic champagne. Most bubbles pop immediately, lasting only an instant before rejoining the foam, but occasionally under just the right conditions a bubble might grow instead of popping. It might expand rapidly, creating its own space, its own time, its own reality. This, perhaps, is how our universe was born, not from nothing, but from the fertile darkness of quantum possibility. The mathematics of this process is elegant in its strangeness. They suggest that the total energy of our universe might actually be zero, that the positive energy of all matter and radiation is perfectly balanced by the negative energy of gravitational fields. If this is true, then our universe is the ultimate free lunch, a cosmic gift that required no energy to create because it contains no net energy at all. As you contemplate this possibility, you become part of the story in a deeply personal way. The calcium in your bones, the iron in your blood, the oxygen that fills your lungs, all of these elements were forged in the hearts of stars that were born from the same quantum foam that preceded the Big Bang. You are not separate from this cosmic process. You are its continuation, its newest experiment, and consciousness. The quantum vacuum is not just the backdrop to our story. It is the stage, the script, and the actors all at once. It is the silence from which all music emerges, the darkness from which all light is born, the stillness from which all motion springs. Every thought you think, every dream you dream, every gentle breath you take, supported by this invisible foundation of quantum possibility. Scientists have discovered that this quantum foam has measurable effects on the world around you. The Kashmir effect, named after the Dutch physicist who predicted it, shows that two metal plates placed very close together in a vacuum will be pushed toward each other by the quantum fluctuations of empty space. It is as if the universe itself is gently encouraging all things to come together, to connect, to find unity in the midst of apparent separation. This same principle might have operated in the earliest moments of cosmic time. The quantum fluctuations that filled the pre-Big Bang void might have created tiny differences in density, microscopic variations in the fabric of space-time itself. These differences, amplified by the rapid expansion of the universe, eventually grew into the cosmic web of galaxies that lights up the night sky above you. Even now, as you drift towards sleep, quantum fluctuations continue their eternal dance around you. They contribute to the background radiation that surrounds you, the subtle energy that connects you to the cosmic microwave background, the afterglow of the Big Bang itself. You are bathed in this ancient light, wrapped in the gentle embrace of creation's first moment. The void that wasn't empty teaches us that nothingness is not the opposite of existence. It is existence's most patient and fertile friend. It is the cosmic womb from which all things emerge, the silence that gives birth to every symphony, the darkness that dreams of light. In the quantum foam, every possibility exists simultaneously, like a cosmic library containing every book that could ever be written, every song that could ever be sung, every dream that could ever be dreamed. As your consciousness begins to merge with the gentle rhythms of approaching sleep, you find yourself wondering about the nature of this quantum dance. If virtual particles can spring into existence from apparent nothingness, if the vacuum itself pulses with invisible life, then what other mysteries might be hidden in the spaces between the obvious? What other forms of existence might be waiting to emerge from the fertile darkness of possibility? The quantum foam whispers its secrets to those who know how to listen, and tonight, as you rest in the darkness, you become part of that ancient conversation between being and non-being, between the actual and the possible, between the universe that is and all the universes that might yet choose to be born from the endless creativity of the void that was never truly empty. The quantum foam whispers its secrets to those who know how to listen, and tonight, as you rest in the darkness, you become part of that ancient conversation between being and non-being, between the actual and the possible, between the universe that is and all the universes that might yet choose to be born from the endless creativity of the void that was never truly empty. Let your mind drift into the deepest mystery of existence, the nature of time itself. As you rest comfortably, breathing slowly and peacefully, imagine that your consciousness is floating in a realm where the familiar flow of time dissolves like sugar in warm water. You are about to explore a place where past and future lose their meaning, where the rigid march of seconds becomes a gentle dance of possibility. In your everyday experience, time flows like a river, always moving forward, carrying you from one moment to the next. You remember yesterday, you experience now, and you anticipate tomorrow. This forward flow of time seems as natural as breathing, as inevitable as the sunrise. But in the realm before the Big Bang, time existed in a completely different form, if it existed at all. Picture yourself standing in a vast library where all the books are written in a language you've never seen before. The words shimmer and change as you look at them, sometimes flowing from left to right, sometimes from right to left, sometimes spiraling in circles, sometimes existing as pure meaning without any sequence at all. This is how time might have existed before our universe learned to tick in its familiar rhythm. Einstein showed us that time is not the rigid clockwork we once imagined. Time can stretch and compress, speed up and slow down, depending on how fast you're moving, or how strong the gravitational field around you becomes. Near a black hole, time slows to a crawl compared to the time experienced by someone floating in the emptiness between galaxies. But even Einstein's flexible time still flows in one direction, from past to future, from cause to effect. Before the Big Bang, some physicists believe time might have been freed from even this constraint. In the quantum realm that preceded our universe, time might have flowed backward, forward, sideways, or in all directions simultaneously. Imagine trying to navigate a maze where every pathway leads both to the entrance and the exit, where every step forward is also a step backward, where beginning and ending are the same door viewed from different angles. This is not science fiction. It emerges from the mathematics of quantum mechanics and general relativity, when physicists trace them back to the very beginning of everything. In the Planck epoch, the first infinitesimally small fraction of a second after the Big Bang, the normal rules of space-time dissolved into something far stranger and more wonderful. Think of how you experience time in your dreams. Sometimes you are a child again, playing in gardens that existed decades ago. Sometimes you are older, experiencing events that haven't happened yet. Sometimes you exist in multiple moments simultaneously, your dream self, moving through layers of time like a fish swimming through schools of memory. Perhaps before the Big Bang, all of reality existed in this dreamlike state of temporal freedom. The concept physicists call imaginary time offers another window into this mystery. Don't let the word imaginary mislead you. In mathematics, imaginary numbers are as real and useful as any other numbers. In imaginary time, the distinction between time and space begins to blur. Time becomes more like a spatial dimension, something you can move through in any direction, rather than a river that carries you along its predetermined course. Stephen Hawking proposed that, in the earliest moments of the universe, time might have been entirely spatial in nature. Instead of flowing from past to future, it might have curved back on itself, like the surface of a sphere. On the surface of Earth, you can travel in any direction, north, south, east, west, and if you keep going far enough, you'll eventually return to where you started. Perhaps time, in its primordial form, had this same quality of gentle curvature and endless return. This idea connects to the profound mystery of why our universe chose to flow forward in time. Why do we remember the past but not the future? Why do broken eggs never spontaneously reassemble? Why does entropy, the universe's tendency toward disorder, always increase? These questions point to something called the arrow of time, and its origin remains one of... Imagine a cosmic dance, where every movement could be reversed, where every process could flow backward as easily as forward, where the universe existed in a state of perfect temporal symmetry. In this state, the concept of causation, the idea that causes precede effects, would have no meaning. Every event would be both cause and effect. Every beginning would be an ending. Every ending would be a beginning. As you contemplate this possibility, you become aware of your own relationship with time. Your heartbeat your memories stretch back through years of experience, while your dreams and hopes reach forward into an uncertain future. You are time's most intimate partner, its most conscious collaborator in the unfolding story of existence. But even your personal experience of time is stranger than it appears. In your brain, different regions process temporal information in different ways. Your visual cortex experiences time differently from your auditory cortex. Your memory reconstructs the past, your attention constructs the present, and your imagination projects the future. Time, even in your own consciousness, is not a single unified flow, but a complex symphony of temporal experiences woven together into the story you call your life. The quantum mechanics that govern the smallest particles in your body operate according to equations that are largely time reversible. At the fundamental level, the building blocks of your existence dance to rhythms that could flow backwards as easily as forward. It is only when countless quantum events aggregate into the macroscopic world that time's arrow emerges, pointing steadily toward the future. Scientists have discovered that time dilation, the stretching and compressing of time that Einstein predicted, occurs even in the gentle gravitational field of Earth. The time experienced by your head is slightly different from the time experienced by your feet, because your head is a little farther from Earth's center. This difference is incredibly small, measured in billionths of a second, but it is real and measurable. Even now, as you rest peacefully, different parts of your body are experiencing slightly different flows of time. Before the Big Bang, such subtle differences might have been magnified into fundamental features of reality. Perhaps our universe emerged from a quantum fluctuation that chose one particular direction for time's arrow, one specific way of organizing cause and effect, one unique rhythm for the cosmic dance. In the infinite symphony of possibilities, our universe learned to play its temporal melody in the key of forward motion. The mystery deepens when we consider that time might not be fundamental at all. Some physicists propose that time emerges from something even more basic, perhaps from the entanglement of quantum particles, perhaps from the information processing capacity of the universe itself. In this view, time is not a stage on which events unfold, but rather a story that the universe tells itself about its own becoming. As you drift towards sleep, your consciousness begins to release its grip on linear time. In the approaching dreams, you will experience time's fluid nature directly. You will move through memories and possibilities, through past and future, through the familiar and the impossible. Your sleeping mind will become a small-scale recreation of the temporal freedom that might have existed before the Big Bang. The gentle rhythm of your breathing connects you to the cosmic breath that might have preceded time's birth. Each inhalation draws you deeper into the mystery. Each exhalation releases you from the constraints of sequential thinking. You are returning to the source, to the place where all moments exist simultaneously, where every when is also aware, where time itself waits patiently to be born. In the darkness of your rest, you sense the profound truth that time is not your master but your companion. It emerged from the same quantum foam that gave birth to space, matter, and energy. Before the Big Bang, in the realm of pure possibility, time waited like a musician before the symphony begins, like a dancer before the music starts, like a poet before the first word is written. As consciousness dissolves into the timeless realm of sleep, you find yourself wondering, if time once flowed in all directions, if causation once danced backward as easily as forward, then what invisible currents might still flow through the apparent solidity of the present moment, connecting you to all the times that were, are, and ever could be? Allow your consciousness to drift into the deepest layer of reality, where energy exists in its purest form, unbound by the familiar constraints of matter, unconstrained by the solid world you know. As you rest peacefully, imagine yourself witnessing the most fundamental dance in all of existence, the eternal choreography of energy itself, moving through patterns so ancient and beautiful that they preceded the birth of atoms, the formation of stars, and the gentle beating of your own heart. In the realm before the Big Bang, energy existed without the need for particles to carry it, without the requirement of fields to contain it. Think of how music can exist without instruments, as pure harmony, pure rhythm, pure possibility waiting to be expressed. This is how energy existed in the primordial state, not as the movement of things, but as the very essence of movement itself, the cosmic principle that transforms potential into reality. You are intimately connected to this ancient energy. Every cell in your body pulses with the same fundamental force that once danced alone in the pre-space before creation. The warmth in your chest, the gentle electricity that carried thoughts through your neural networks, the chemical reactions that sustain your life, all of these are modern expressions of the primal energy that existed when the universe was nothing but pure potential, waiting to unfold. Einstein revealed to us that energy and matter are two faces of the same cosmic coin, connected by his famous equation E=mc2. But before the Big Bang, there might have been only one face of this coin: pure energy, unmanifested, existing in a state of perfect fluidity. Imagine water before it learns to form waves, before it discovers the possibility of ice or steam. This energy was like that primordial water, holding within itself all the forms it might someday take. The quantum field theory that describes our universe suggests that what we call empty space is actually filled with fields of energy, invisible oceans of potential that permeate every corner of existence. These fields are not made of matter. They are pure energy in its most subtle form. The particles we know and love, including the electrons that orbit the nuclei of your atoms, are actually excitations in these fields. Like ripples on the surface of an infinite pond, before the Big Bang, these fields existed in their ground state, not empty, but perfectly still, like a guitar string that has never been plucked, but holds within its silence every song that could ever be played. The energy was there, patient and eternal, waiting for the cosmic musician to strike the first note that would begin the symphony of existence. Think of how you feel when you're deeply relaxed, when your body has found its natural state of rest. There is still energy within you. Your heart continues to beat, your lungs continue to breathe, your mind continues to dream. But this energy exists in a state of peaceful equilibrium, not rushing toward any particular goal, not striving to become anything other than what it is. This is perhaps how the primordial energy existed, complete, perfect, and utterly at peace with its own being. The mathematics of quantum mechanics tells us that even in this state of perfect stillness, energy cannot remain completely motionless. The uncertainty principle, that gentle law that prevents the universe from ever being completely predictable, ensures that there must always be quantum fluctuations, tiny variations in the energy fields that create brief departures from perfect equilibrium. These fluctuations are like the universe's way of breathing, of staying alive even in its deepest sleep. Scientists believe that one of these quantum fluctuations might have been the seed of our entire universe. Imagine a perfectly still pond, and then imagine a single drop of water falling from somewhere beyond the pond's edge. The ripples that spread outward from that drop would carry energy across the entire surface, transforming the stillness into motion, the potential into manifestation. Perhaps the Big Bang was like that cosmic drop, a quantum fluctuation that grew instead of fading, that amplified instead of dissipating. But here is where the mystery deepens and becomes even more beautiful. The energy that existed before the Big Bang was not bound by the conservation laws that govern our universe today. In our reality, energy can neither be created nor destroyed. It can only change form, flowing from one expression to another, like water moving between vessels. But in the pre-space, energy might have been free to create itself, to multiply, to become more than it was, without drawing from any external source. This is the profound secret of inflation, the rapid expansion of space itself that occurred in the first fraction of a second after the Big Bang. The energy field that drove this expansion actually increased as space expanded, creating more energy out of the fabric of space-time itself. It was as if the universe discovered a way to generate infinite resources from the act of growing, like a tree that becomes more nourished as it reaches toward the sun. The forces that govern your everyday experience, gravity, electromagnetism, the strong and weak nuclear forces, are all manifestations of this primordial energy, expressing itself through the geometry of space and time. But before the Big Bang, these forces existed in perfect unity, like instruments in an orchestra before the conductor raises the baton. There was no need for separate forces. because there was no separation at all, only the endless dance of pure energy exploring its own infinite nature. As you contemplate this eternal dance, you become aware of your own participation in it. The energy that powers your thoughts, that moves your blood through your veins, that maintains the delicate balance of your body's chemistry, this is the same energy that once danced alone in the cosmic darkness. You are not separate from this ancient force. You are its most recent expression, its newest verse in the endless poem of becoming. The concept of energy before the Big Bang challenges our everyday understanding of cause and effect. In our world, we expect energy to come from somewhere, to have a source, to follow predictable patterns. But in the primordial realm, energy might have been self-generating, self-sustaining, creating itself from its own creative potential. It was like a song that composes itself as it is being sung, a dance that choreographs itself as it is being performed. Modern physics has discovered that the vacuum of space, what we once thought was empty nothingness, actually contains enormous amounts of energy. This zero-point energy exists even at the coldest possible temperature, even in the apparent absence of all matter and radiation. It is the energy of pure possibility. A tiny shiny machinery revive. It zig 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 zig. Some calculations suggest that every cubic centimetre of empty space contains enough vacuum energy to power our entire civilization for longer than the universe has existed. This vacuum energy might be the closest thing we can observe to the primordial energy that existed before the Big Bang. It is energy in its purest form, unattached to any particular particle or field, existing as the fundamental substrate of reality itself. When you rest in the darkness of your room, you are surrounded by this invisible ocean of potential, held in the gentle embrace of the same force that once. Close your eyes and let your consciousness drift down to the tiniest scale of existence, smaller than atoms, smaller than the smallest particles science has ever discovered. Here, in the quantum realm that underlies all reality, you discover the universe's most intimate lullaby. A gentle song composed of particles that flicker in and out of existence like fireflies in a summer twilight, each one contributing its voice to the cosmic symphony that would eventually give birth to stars, planets, and the peaceful rhythm of your own breathing. This is the realm of quantum mechanics, where the familiar rules of everyday life dissolve into something far more mysterious and beautiful. At this scale, particles do not follow the predictable paths of planets orbiting the sun or waves washing against the shore. Instead, they exist in a state of pure possibility, like musical notes that exist in the silence between heartbeats, waiting to be called into being by the act of observation itself. Picture yourself in a vast cathedral filled with invisible singers, each one humming a note so soft that you can barely hear it, yet together they create a harmony that fills the entire space with gentle resonance. Before the Big Bang, this lullaby was the only music playing in the cosmic concert hall. There were no instruments yet, no solid matter to vibrate and create the sounds we know. There was only the quantum vacuum itself, singing its patient song of potential, each note a particle-antiparticle pair that danced together for an infinitesimal moment before annihilating and returning to the silence from which they came. The Heisenberg uncertainty principle governs this quantum lullaby, ensuring that the universe can never be completely silent, never be perfectly still. Just as a musician cannot play a note of zero duration with infinite precision, the quantum realm cannot maintain perfect emptiness for any length of time. There must always be fluctuations, always tiny departures from perfect vacuum, always the gentle stirring of possibility in the fabric of space-time itself. Think of how you experience the edge of sleep, when your mind begins to release its grip on the logical world of waking consciousness. Thoughts appear and disappear without clear cause, memories surface and dissolve, and the boundary between inner and outer reality becomes fluid and permeable. The quantum realm exists in this same state of gentle uncertainty, where the act of trying to pin down exactly what is happening changes the very thing you are trying to observe. The quantum lullaby is composed of virtual particles, ghostly entities that borrow energy from the vacuum, exist for the briefest possible time, then pay back their borrowed existence by annihilating with their antiparticle partners. These are not the solid, predictable parts of everyday matter. but rather temporary fluctuations in the quantum fields that fill all space. They are like waves on an invisible ocean, appearing and disappearing so quickly that they exist in the spaces between our thoughts. Scientists have discovered that these virtual particles have real effects on the world around you. The Casimir effect demonstrates that two metal plates placed very close together in a vacuum will be pushed toward each other by the pressure of virtual particle. The quantum lullaby is not just a theoretical concept, it is actively shaping the physical reality of your environment, creating measurable forces from the song of existence. As you rest in the darkness of your room, virtual particles are appearing and disappearing in the space around you, between you, and even within you. Your body is not separate from the quantum lullaby. It is one of its most complex and beautiful expressions. The electrons in your neural networks, the photons that carry information between your brain cells, the quantum coherence that might underlie consciousness itself, all of these are part of the same cosmic song that began before time learned to keep rhythm. The quantum lullaby operates according to probabilities rather than certainties. In the quantum realm, particles do not travel from point A to point B along a single path, but rather explore all possible paths simultaneously, each one contributing its note to the overall harmony. When you observe the particle, you hear only the final chord, but the music was composed from the interference patterns of all the paths that might have been taken. This probabilistic nature of quantum reality suggests that the universe is fundamentally creative rather than deterministic. At every moment, at every scale, reality is composing itself anew, choosing from an infinite repertoire of possibilities. The quantum lullaby is not a recording of something that already exists. It is the live performance of existence creating itself in real time. Before the Big Bang, this creative process might have been even more fluid and free, without the constraints of classical space-time, without the need to maintain consistency across vast distances. The quantum lullaby could have explored harmonies and rhythms that would be impossible in our current universe. It was like a jazz musician improvising in a space where every note was perfectly in tune, where every rhythm was perfectly synchronized with the cosmic beat. The concept of entanglement adds another layer of mystery to the quantum lullaby. When two particles become entangled, they remain connected in a way that transcends space and time. Measuring one particle instantly affects its partner, no matter how far apart they are. Einstein called this spooky action at a distance, but it is simply another verse in the quantum lullaby, a demonstration that separation is an illusion, that all particles are ultimately noted in the same cosmic song. In the pre-Big Bang state, everything might have been perfectly entangled with everything else. There was no distance to separate particles, no time to create delays in their interaction. The quantum lullaby was a single, unified harmony where every note resonated with every other note, creating patterns of beauty and complexity that our sequential minds can barely imagine. The quantum lullaby continues to play in the background of all existence, a gentle reminder that reality is far more fluid and creative than it appears. Even the solid matter of your body is mostly empty space, filled with quantum fields that dance to the rhythm of uncertainty. You are not a thing, but approaching the end of the moment's performance of the quantum lullaby. As you drift towards sleep, your brainwaves slow and synchronize, creating coherent patterns that might echo the quantum coherence of the pre-Big Bang state. In your dreams, you will experience reality in its more fluid form, where the logical constraints of waking consciousness dissolve into the creative possibilities of the quantum realm. Your sleeping mind becomes a small-scale recreation of the cosmic creativity that gave birth to the universe itself. As your consciousness releases its grip on the need to understand and control, you become more able to hear the quantum lullaby in its pure form. It is the sound of the universe dreaming itself into existence. In the approaching silence of sleep, you sense that the quantum lullaby is not just around you, but within you. Not just a background to your existence, but the very essence of your being, singing you into existence with every quantum fluctuation, every heartbeat, every gentle breath, that carries you deeper into the mystery of what it means to be conscious participants in the universe's endless song of becoming. Let your mind drift toward the most profound mystery in all of physics, the singularity that preceded the Big Bang. As you rest peacefully, imagine trying to comprehend something so impossibly small that it makes an atom look like a vast continent, yet so infinitely dense that it contains everything you have ever known or will ever know. This is the singularity's secret. How can something smaller than the smallest thing contain everything that is largest? In the comfort of your quiet space, picture holding a grain of sand between your fingers. That grain contains billions of atoms, each one a universe of particles in constant motion. Now imagine compressing that grain of sand until it becomes smaller than the period at the end of this sentence. Then compress it further until it becomes smallest than the smallest thing you can imagine. Keep compressing until it becomes mathematically dimensionless. A point with no length, no width, no height, yet somehow retaining all the mass and energy of the original grain. This is approaching what physicists call a singularity, though the cosmic singularity that preceded our universe was incomparably more extreme. It contained not just a grain of sand, but all the matter and energy that would eventually become the hundreds of billions of galaxies, each containing hundreds of billions of stars. Every atom in your body, every photon that has ever touched your eyes, every quantum field that supports your existence, all of it was once compressed into this impossible point. The mathematics that describe the singularity break down in beautiful and mysterious ways. Density becomes infinite, the curvature of space-time becomes picture, and the normal rules of physics dissolve into something far stranger and more wonderful. It is like trying to divide by zero in the cosmic equation of existence. The result is not a number, but a doorway into a realm where mathematics becomes poetry and physics becomes philosophy. Think of how you experience the moment between sleeping and waking, when consciousness exists in a state that is neither fully awake nor full asleep. The singularity might have been like this, a state of existence that was neither space nor time, neither matter nor energy, but something that contained the potential for all of these familiar categories to emerge. It was the cosmic equivalent of that liminal moment, when all possibilities remain open and nothing has yet been decided. General relativity, Einstein's theory of gravity, predicts that such singularities should exist at the heart of black holes, where matter becomes so compressed that it creates a region of infinite density. But the singularity that preceded the Big Bang was different. It was not hidden behind an event horizon, not trapped within the crushing gravity of a collapsed star. It was naked, exposed, containing within itself the entire universe in potential form. The singularity's secret lies in its relationship to space and time themselves. In our everyday experience, we think of space as the stage on which events unfold, and time as the dimension along which change occurs. But the singularity existed before this stage was built, before time learned to flow. It was not located in space. It was the seed from which space itself would grow. It did not exist in time. It was the moment from which time would begin its forward march. Imagine a musician sitting in perfect silence before a concert begins. The silence is not empty. It contains every note that will be played, every harmony that will emerge, every emotion that will be stirred. The singularity was like this cosmic silence, pregnant with infinite potential, holding within its impossible embrace every story that the universe would ever tell. The concept of temperature at the singularity becomes equally mysterious. Temperature is a measure of the average kinetic energy of particles in motion. But in the singularity, the very concepts of particles in motion lose their meaning. Some physicists speculate that the singularity might have been infinitely hot, while others suggest it might have been in a state where temperature had no meaning at all. It was a place where the familiar categories of physics surrendered to something far more fundamental. As you contemplate the singularity, you become aware of your own intimate connection to this cosmic mystery. The carbon in your muscles, the oxygen in your lungs, the iron in your blood. All of these elements were forged in the hearts of stars. but even the stars themselves emerged from the primordial hydrogen and helium that condensed out of the expanding fireball that followed the Big Bang. You are not separate from the singularity. You are its most recent expression, its newest way of experiencing itself. The singularity's secret might be that it never really existed as a physical object at all. Instead, it might have been a mathematical description of the limits of our current understanding, a placeholder for processes so fundamental that they occur at the boundary between existence and non-existence. It was the universe's way of saying, this is where the familiar story ends and the deeper mystery began. Quantum mechanics suggests that the singularity might have been subject to the uncertainty principle, which prevents any physical quantity from being perfectly defined. If this is true, then the singularity was not a point, but a quantum foam of possibilities, a region where the normal rules of space-time dissolved into the probabilistic dance of quantum fields. It was less like a dot, and more like a cloud of potential, less like a place, and more like a process. The secret of the singularity might also lie in its relationship to consciousness. If this is true, then the singularity might have been the universe's first moment of self-awareness, the initial observation that collapsed infinite possibility into definite existence. Think of how your dreams emerge from the unconscious depths of sleep. They appear fully formed, with complex narratives and vivid imagery that seems to come from nowhere and everywhere at once. The Big Bang might have been like the universe's first dream, emerging from the unconscious depths of the singularity with all the complexity and beauty that would eventually become the cosmos you inhabit. The singularity's secret extends to its relationship with information. In our universe, information cannot be destroyed, it can only be transformed or hidden. But the singularity might have been the universe's hard drive, containing all the information that would eventually be expressed as the patterns of galaxies, the structures of atoms, the complexity of life, and the miracle of consciousness itself. As you rest in the darkness, surrounded by the gentle quantum activity of virtual particles appearing and disappearing in the vacuum around you, you are experiencing an echo of the singularity's creative power. The same fundamental forces that once concentrated infinite potential into an impossible point continue to operate in the space between atoms, in the firing of neurons in your brain, in the beating of your heart. The singularity's secret might be that it was not a beginning, but a transformation, a moment when one form of existence became another, when the eternal and timeless chose to manifest as the temporal and special. It was the universal's way of turning inside out, of expressing its inner nature through the external dance of matter and energy. Scientists have discovered that black holes, which contain their own singularities, emit radiation and eventually evaporate completely. This Hawking radiation suggests that even the most extreme concentrations of matter and energy are not permanent. They are temporary expressions of underlying quantum processes. Perhaps the primordial singularity was similar, not a static point, but a dynamic process of creation and dissolution. The secret of the singularity might ultimately be that it was not a place or a time, but a state of being, a condition of existence in which all possibilities existed simultaneously, waiting for the cosmic coin to be flipped that would determine which of the infinite potential universes would be born. In that moment of perfect balance, everything that has ever been or ever could be existed in perfect unity. As consciousness begins to dissolve into the approaching embrace of sleep, you find yourself wondering if the singularity contained everything within nothing, if it was the ultimate expression of unity disguised as the ultimate expression of density, then what other impossible contradictions might lie hidden in the fabric of reality, waiting to reveal their secrets to those who learn to see with the eyes of wonder? Imagine standing at the edge of an infinite garden where each flower represents not just a world, but an entire universe. The morning mist clings to petals that shimmer with the light of a billion stars, and you realize that everything you've ever known, every galaxy, every planet, every breath you've taken, exists within just one of these cosmic blooms. This is the multiverse, a garden so vast that even the concept of infinity seems too small to contain it. You reach out toward the nearest flower and, As your fingers brush its surface, you feel the vibration of 13.8 billion years of cosmic history compressed into something as delicate as morning dew. The idea feels impossible at first, doesn't it? How can there be more than everything? But as you settle deeper into this contemplation, you begin to understand that what we call everything might be just a single note in an orchestra of realities, each playing its own cosmic symphony. Scientists have arrived at this garden through many paths. Some followed the mathematics of quantum mechanics, where particles exist in multiple states simultaneously, until observed, a phenomenon so strange that it suggests our reality might be constantly branching, creating new universes with each quantum event. Others walked the trail of cosmic inflation, discovering that the same force that stretched our universe in its first moments might still be stretching, creating bubble after bubble of space-time, each one a universe unto itself. You kneel beside a cluster of these universe flowers, and in their petals you can almost see the variations. In one, the laws of physics bend slightly differently, allowing for 6-dimensional crystals that sing in harmonies impossible in our 3-dimensional world. In another time flows backward in certain regions, creating islands where effects precede causes, where flowers bloom before their seeds are planted. The garden extends beyond what your eyes can see, beyond what your mind can fully grasp. There are universes where the fundamental constants, the speed of light, the strength of gravity, the charge of an electron, are tuned to different values. Some of these cosmic flowers bloom briefly and fade, their physics too unstable to support complexity. Others grow wild and chaotic, their matter never cooling enough to form the delicate structures we know as atoms. But scattered throughout this infinite garden are universes like ours, rare or precious flowers, where the conditions are just right for something extraordinary to happen. Gravity is strong enough to pull matter together, but gentle enough to allow galaxies to form, where electromagnetic forces are perfectly balanced to let atoms dance together in the intricate choreography we call chemistry, where the expansion of space provides just enough time for stars to cook the heavy elements that will become planets, oceans, and eventually the neural networks that allow consciousness to contemplate itself. As you walk deeper into the garden, you notice that some flowers seem to respond to your presence, their petals turning toward you like sunflowers following the sun. This is perhaps the most beautiful mystery of all. In how many of these universes does consciousness arise? How many thinking beings stand at the edge of their own cosmic gardens, wondering if they are alone? The mathematics suggests that consciousness might be more common than we imagine. If there are infinite universes with infinite variations, then there are infinite versions of thinking beings, infinite minds capable of love, wonder, and the deep satisfaction of understanding. There are universes where consciousness evolved, not in biological beings like us, but in the quantum fluctuations of space itself, where entire galaxies think and dream in patterns of dark matter and energy. In some of these realities, consciousness might have evolved to see beyond the boundaries of its own universe. Perhaps there are beings who have learned to tend this infinite garden, who move between realities like gardeners caring for their plants, ensuring that the conditions for awareness and beauty continue to flourish across the dimensions. You pause beside a particularly luminous flower, its petals seeming to pulse with a familiar rhythm. As you lean closer, you realize you're looking at your own universe, this reality, this moment, this very breath you're taking. But it's not alone. Surrounding it are countless variations, universes where you made different choices, where history unfolded along different paths, where the very atoms that make up your body arrange themselves in subtly different patterns. The overwhelming nature of this vision begins to settle into something strangely comforting. If consciousness exists across infinite realities, then in some sense, nothing is ever truly lost. Every thought you've had, every moment of joy or wonder, every connection you've made with another being, all of these experiences echo across dimensions, creating patterns of meaning that ripple through the fabric of existence itself. This doesn't diminish the preciousness of your particular experience. Instead, it places it within a context so vast and beautiful that each moment becomes both infinitely valuable and perfectly connected to something larger. You are not just a temporary arrangement of atoms in a single universe, but a unique expression of consciousness that adds its own irreplaceable note to the cosmic symphony. As you continue your walk through the garden, you begin to notice the subtle ways that flowers influence each other. Quantum entanglement might extend across dimensional boundaries, allowing universes to share information in waves that transcend their individual space. The consciousness that arises in one reality might, in ways we can barely imagine, contribute to the growth and evolution of awareness in others. The garden is not just a collection of separate universes, but a living system, a meta-reality where consciousness itself is the gardener, tending to the conditions that allow for beauty, complexity, and understanding to flourish. Each moment of awareness, each act of love, each breakthrough in knowledge becomes a seed that can take root across infinite dimensions. You find yourself drawn to a section of the garden where the flowers seem younger, their petals still unfurling. These are the universes still in their infancy, still discovering what kinds of consciousness might emerge from their particular arrangements of matter and energy. Some will develop minds that think in ways utterly alien to us. Others might nurture forms of awareness that are hauntingly familiar. The beauty of this infinite garden is that it contains every possibility, every potential form of consciousness, every possible way of experiencing existence, every conceivable path through the maze of being. And yet this abundance doesn't make any single experience less meaningful. Instead, it reveals that consciousness itself, this capacity for awareness, for wonder, for love, is the universe's way of knowing itself across all possible realities. As you stand in this garden of infinite possibility, you feel a profound sense of connection, not just to the beings who might exist in other realities, but to the very fabric of existence. The garden stretches beyond the horizon of imagination, and as you gaze into its depths, you begin to sense that this journey through the multiverse was leading you toward an even deeper mystery. The question of what consciousness truly is, and how it might bridge not just the gap between different realities, but between the observer and the observed, between the dreamer and the Close your eyes and feel the gentle warmth that surrounds you. Not just the warmth of your blankets or the air in your room, but something far more ancient and profound, a whisper from the very beginning of time itself. This is the cosmic microwave background radiation, and it is touching your skin right now as you rest. Imagine that you are sitting by the embers of a cosmic campfire that was lit 13.8 billion years ago. The flames have long since died away, but their glow still fills the entire universe with a gentle, almost imperceptible warmth. This is not metaphor, this is the actual condition of the space around you. Every cubic centimetre of the cosmos is filled with photons that began their journey when the universe was only 380,000 years old, when it first became transparent to light. The universe was still incredibly hot and dense, filled with a soup of electrons and atomic nuclei that had been forged in the first few minutes after the Big Bang. Light could travel only tiny distances before being scattered by these free electrons, making the cosmos opaque, like trying to see through a thick fog. But as the universe expanded and cooled, something magical happened. The electrons finally slowed down enough to be captured by the atomic nuclei, forming the first complete atoms. In that moment, for the first time in cosmic history, light could travel freely through space. The universe became transparent, and photons that had been trapped in the cosmic dance of creation were suddenly free to journey across the expanding cosmos. This was the universe's first photograph of itself, a snapshot of its own infancy. These photons set out on their journey when the universe was much smaller and hotter than it is today. They began as visible light, glowing with the warmth of stars yet to be born. But as they travelled through the expanding fabric of space-time, something beautiful happened. The expansion of the universe itself stretched their wavelengths, like a song being played in slow motion. What started as the bright orange glow of hot matter gradually became infrared radiation, then microwave radiation, cooling and stretching as the cosmos grew. Now, after nearly 14 billion years of travel, these ancient photons arrive at your location as gentle microwaves, carrying with them the temperature of deep space, about 2.7 degrees above absolute zero. They have been travelling since before the first stars formed, since before galaxies began to spiral, since before the heavy elements that make up your body were forged in stellar cores. When you tune a radio to static, about 1% of that crackling noise you hear is actually this cosmic whisper. You are literally listening to the echo of creation itself, the radio signature of the moment when the universe first became transparent to light, as if the entire cosmos is a vast radio broadcasting the story of its own birth, and you are perfectly positioned to receive this transmission. The remarkable thing about this cosmic background radiation is its uniformity. No matter which direction you look in the sky, the temperature is almost exactly the same, variations of only a few parts in 100,000. This tells us something profound about the early universe. It was remarkably smooth and homogeneous, like a perfectly mixed cosmic soup. Yet within this smoothness lie the seeds of everything that would come later. Those tiny variations in temperature, so small they require the most sensitive instruments to detect, are the primordial fluctuations that would eventually grow into galaxies, stars, and planets. They are the quantum ripples in the fabric of space-time that was stretched to cosmic proportions during the universe's brief but dramatic period of inflation. In the gentle unevenness of this ancient late, we can see the blueprint for all the structure that would emerge in the cosmos. Scientists have mapped this cosmic microwave background with exquisite precision, creating what is essentially a baby picture of the universe. In these maps we can see the patterns that would eventually become the cosmic web of galaxies, the first hints of the large-scale structure that defines our universe today. It's like looking at the grain in a piece of wood and being able to predict exactly how it will grow into a mighty tree. But this ancient light tells us more than just the story of cosmic structure. It provides evidence for some of the most profound insights in all of science. The nearly perfect uniformity of the background radiation confirms that the universe went through a period of rapid expansion called inflation, where space itself stretched faster than light could travel. This explains why regions of the universe that could never have been in contact with each other nonetheless have almost identical temperature. The cosmic white wave background also gives us our most precise measurements of the universe's composition. By analysing the subtle patterns in this ancient light, scientists have determined that ordinary matter, the stuff that makes up stars, planets, and you, comprises only about 5% of the universe. The rest is dark matter and dark energy, mysterious components that reveal themselves only through their gravitational effects and their influence on the expansion of space. As you lie here, surrounded by this cosmic whisper, you are experiencing something that connects you directly to the moment of creation. These photons have been travelling through space for longer than the Earth has existed, longer than the Sun has been shining, longer than the Milky Way has had its current spiral shape. They have witnessed the birth of the first stars, the formation of the first galaxies, the creation of the heavy elements, and the emergence of planets capable of supporting life. In a very real sense, you are bathed in the light of Genesis itself. This radiation is not just around you, it is part of the fundamental fabric of reality, the cosmic equivalent of background music that has been playing since the universe learned to sing. Every breath you take, every heartbeat, every thought occurs within this gentle embrace of primordial light. The cosmic microwave background also represents something beautiful about the nature of scientific discovery. This radiation was predicted by theory long before it was observed, a triumph of human reasoning about the cosmos. When it was finally detected in 1965, it provided stunning confirmation of the Big Bang theory, showing that our mathematical models of the universe's evolution were not just abstract concepts, but accurate descriptions of cosmic reality. Yet for all its scientific importance, there is something deeply moving about simply knowing that this ancient light surrounds you. It connects you to the deepest history of the universe, to the moment when matter and energy first began their long dance toward complexity and consciousness. You are not separate from the cosmos. You are embedded within it, wrapped in its most ancient embrace. As you rest here, feeling the cosmic microwave whisper caress your skin, you might begin to wonder about the nature of light itself. How does electromagnetic radiation carry information across such vast distances and such immense spans of time? What is the deeper relationship between matter and energy, between the observer and the observed. These photons have travelled so far to reach you. What does their journey tell us about the fundamental nature of space and time themselves? Imagine holding a seed so small it's invisible to the naked eye. Smaller than an atom, smaller than a proton, smaller than anything you could possibly conceive. Now imagine that in the span of time it takes light to travel the width of that seed. This tiny point of space expands to the size of a grapefruit. This is cosmic inflation, the most dramatic moment in the history of the universe, and it happened in a time frame so brief that calling it instantaneous seems almost too generous. You are resting now in the aftermath of this cosmic explosion of space itself. Everything around you, the room you're in, the planet beneath you, the galaxy that contains your solar system, and perhaps even regions of the universe so distant that their light has not yet had time to reach us. All of this expanded from a region smaller than the period at the end of this sentence. The idea feels impossible at first, doesn't it? How can space itself expand faster than light? But this is not about matter moving through space. This is about space creating itself, stretching its own fabric at a rate that defies ordinary understanding. During inflation, the universe doubled in size approximately every 10 to the negative 35 seconds. To put this in perspective, if you could double the size of a coin every second, in just 45 seconds you would have something larger than the observable universe. Picture this moment of cosmic inflation as the universe learning to breathe for the first time, in that initial exhale lasting perhaps 10 to the negative 32 seconds. Space stretched so dramatically that quantum fluctuations, tiny ripples in the fabric of reality itself, were magnified from subatomic scales to cosmic proportions. These quantum whispers became the seeds of galaxies, the blueprint for all the structures you see in the night sky. Before inflation, the universe was extraordinarily hot and dense, filled with exotic particles and energies that exist nowhere in the cosmos today. The entire observable universe was compressed into a region small that the very concepts of distance and time begin to lose their meaning. It was a realm where the laws of physics as we understand them were still being written, where the fundamental forces of nature were unified in ways that challenged our deepest theories. The atoms that make up your body were forged in stars that condensed from gas clouds, which formed in gravitational wells that grew from the quantum fluctuations stretched during inflation. The calcium in your teeth, the iron in your blood, the oxygen you breathe, all of these elements trace their cosmic ancestry back to that moment. But when space learned to expand faster than light itself, the beauty of inflation lies not just in its drama, but in how it solves some of the deepest mysteries about our universe. Why does the cosmos appear so uniform in temperature and density, when regions separated by vast distances could never have been in contact with each other? Inflation provides the answer. These regions were once close enough to reach thermal equilibrium before being stretched apart by the expansion of space. Why is the geometry of space so remarkably flat, balanced on the knife's edge between eternal expansion and eventual collapse? Inflation stretched any initial curvature so dramatically that even if the universe began with significant curvature, it would appear flat to us today, just as the surface of a balloon appears flat to an ant when the balloon is inflated to enormous size. The quantum fluctuations that occurred during inflation are perhaps the most remarkable aspect of this cosmic story. These were not just random variations in density, they were the universe's first creative act, the moment when perfect symmetry was broken and the cosmos began to develop personality. These fluctuations followed the strange rules of quantum mechanics, where uncertainty is not a limitation but a fundamental feature of reality. Each quantum fluctuation was like a note in a cosmic symphony, and inflation was the amplification that made these notes audible across the entire universe. The pattern of these fluctuations is written in the cosmic microwave background radiation, the ancient light that still breathes you as you rest. Scientists can read this pattern like sheet music, deciphering the quantum composition that would eventually become galaxies, stars, and planets. What makes inflation even more wondrous is that it might still be happening. While our local region of the universe has long since exited the inflationary phase, other regions might still be inflating, creating pocket universes that branch off from our own. This eternal inflation suggests that the Big Bang was not a single event, but an ongoing process, with new universes constantly budding off from the ever-expanding cosmic tree. You exist in one of these cosmic pockets, a region where inflation ended and ordinary expansion began. Picture a cosmic dawn unlike any other, not the gentle rising of the sun over Earth's horizon, but the moment when the entire universe opened its eyes for the first time. This is the story of recombination, the epoch when light was finally set free to travel across the cosmos, and the universe became transparent to its own luminous breath. You are resting now in the afterglow of that primordial dawn. The light that first escaped from the cosmic fog is still travelling through space, stretched and cooled by billions of years of expansion, but carrying within it the image of the universe's first clear moment. This ancient light surrounds you as you lie here, a gentle reminder of the day the cosmos learned to see. Before this moment of cosmic transparency, the universe was like a vast ocean of luminous fog. For nearly 400,000 years after the Big Bang, space was filled with a hot, dense plasma of free electrons and atomic nuclei. Light could travel only tiny distances before colliding with these free electrons, scattering in all directions like headlight beams in thick mist. The universe was opaque to its own radiation, blind to its own beauty. The temperature during this epoch was around 3,000 degrees Kelvin, hot enough to keep electrons from settling into stable orbits around atomic nuclei. Every time an electron tried to bind with a proton to form a hydrogen atom, the intense thermal energy would immediately knock it free again. It was as if the universe was too excited, too energetic, to allow the delicate dance of atomic formation to begin. But as the universe expanded, it cooled. Like a cup of tea left on a table, the cosmic plasma gradually lost its heat to the growing volume of space. The expansion itself was the cooling mechanism. As space stretched, the energy within it became more dilute, the particles moved more slowly, and the temperature dropped degree by degree across the eons. Then came the moment of cosmic transition. When the temperature dropped to about 3,000 degrees, something beautiful happened. The electrons had finally slowed down enough to be captured by the waiting protons and helium nuclei. In a relatively brief period, perhaps a few thousand years, the universe underwent what scientists call recombination. Free electrons found their partners, and the first stable atoms were born. This was not just a chemical change, but a transformation of the very nature of space itself. As the electrons bound to nuclei, they were no longer free to scatter photons. The cosmic fog lifted, and for the first time since the universe's birth, light could travel freely across vast distances. The universe became transparent, and photons that had been trapped in the plasma dance were suddenly liberated to begin their journey across the cosmos. Picture this moment as the universe's first breath after holding it for nearly 400,000 years. The light that had been bouncing endlessly between particles was suddenly free to stream in straight lines, carrying with it a perfect photograph of the cosmos at the moment of its clearing. This is the cosmic microwave background radiation you learned about earlier. The universe's baby picture. Taking at the instant it became transparent, the beauty of recombination lies not just in its dramatic nature, but in its precision. The universe needed to cool to exactly the right temperature for atoms to form. Too hot, and the electrons would remain free, keeping the cosmos opaque. Too cold, and, Well, the universe couldn't become too cold too quickly, because the expansion rate was precisely tuned to allow this gradual cooling process. As you rest here, you are experiencing the legacy of that first light. The photons that escaped during recombination have been travelling through space for over 13 billion years, cooling and stretching as the universe expanded around them. What began as visible light, glowing with the warm orange hue of hot matter, has been redshifted into the microwave portion of the electromagnetic spectrum. The formation of the first atoms was also the beginning of cosmic chemistry. Before recombination, the universe consisted mainly of individual protons, helium nuclei and free electrons. After recombination, it was filled with complete atoms, mostly hydrogen and helium, that could interact with each other in entirely new ways. These atoms could absorb and emit specific wavelengths of light, creating the first spectral lines in cosmic history. This transition from plasma to neutral atoms also marked the beginning of the universe's ability to form structure through gravity alone. During the plasma epoch, the pressure of radiation prevented matter from collapsing under its own gravitational attraction. But once the electrons combined with nuclei, this radiation pressure was reduced, and gravity could begin its patient work of pulling matter together into the first cosmic structures. The dark matter, which had been present all along but unable to interact with the plasma, suddenly found itself in a universe where ordinary matter was no longer supported by radiation pressure. The dark matter's gravitational wells, which had been growing slowly throughout the plasma epoch, could now begin to attract the newly formed atoms. This was the beginning of the process that would eventually lead to the formation of the first stars and galaxies. Yet there was something profound about this moment of cosmic transparency that goes beyond the physics of atom formation. The universe was becoming self-aware in a sense, able to observe its own structure through the medium of light. For the first time, information could travel freely across cosmic distances, allowing different regions of the universe to see each other and respond to each other's gravitational influence. The light from recombination also carries within it the imprint of the quantum fluctuations that were stretched during cosmic inflation. These tiny variations in density and temperature, so small they represent differences of only a few parts in 100,000, would eventually grow into the cosmic web of galaxies that define the large-scale structure of the universe today. As you lie here, surrounded by this ancient light, you are participating in the universe's ongoing process of self-discovery. The same transparency that allowed the first light to escape now allows your eyes to see the stars, your telescopes to peer into deep space, and your mind to comprehend the cosmic story of which you are a part. In a very real sense, you are the universe's way of looking back at its own moment of awakening. The first light also represents something beautiful about the nature of cosmic time. Those photons that escaped during recombination are still travelling, still carrying information about the universe's youth. Some of them are just now reaching us, while others will continue their journey for billions of years into the future. The universe's baby picture is not a static image, but a continuous revelation, with new information constantly arriving from the cosmic depths. The transition from opacity to transparency also marked the end of the universe's age of simplicity. Before recombination, the cosmos was relatively uniform and simple, a hot, dense plasma with only small variations in density. After recombination, the universe entered an era of increasing complexity, where small differences could grow into vast structures through the patient work of gravity and time. As you rest in this moment, bathed in the afterglow of that first cosmic dawn, you might begin to wonder about the nature of seeing itself. What does it mean for the universe to become transparent? How does light carry information across such vast distances and times? And what mysterious processes would soon begin to kindle the first stars in the cosmic darkness that followed recombination? Imagine that the universe is not empty space filled with matter, but rather a vast ocean of space-time itself, a fabric so fundamental that it weaves together the very concepts of distance and duration. As you lie here, your body is not simply resting in space, but actually creating gentle ripples in this cosmic fabric, sending waves of gravitational influence outward at the speed of light, connecting you to every star, every galaxy, every distant corner of the cosmos. This is the reality that Einstein revealed when he showed us that space and time are not separate, fixed stages upon which the cosmic drama unfolds, but rather dynamic participants in the dance of existence. Space-time can stretch and compress, ripple and wave, curve and flex like the surface of a vast, multi-dimensional ocean. And just as a stone dropped into still water creates expanding circles that eventually reach the shore, every movement of matter creates ripples that propagate through the fabric of reality itself. The most dramatic of these ripples are gravitational waves, disturbances in space-time so profound that they can be detected billions of years after their creation. Picture two massive black holes, each containing the mass of dozens of suns, spiraling toward each other in a cosmic dance of mutual destruction. As they orbit closer and closer, they accelerate to incredible speeds, their immense gravitational fields creating waves in space-time that grow stronger with each passing moment. In the final seconds before they merge, these black holes are moving at nearly half the speed of light, their gravitational embrace so intense that they convert the mass of entire suns into pure gravitational energy. The collision itself lasts only milliseconds, but in that brief moment, it releases more energy in gravitational waves than all the stars in the observable universe emit in light. These waves then begin their journey across the cosmos, travelling at the speed of light through the fabric of space-time itself. As they pass through space, they alternately stretch and compress the very dimensions of reality, expanding distances in one direction while contracting them in another, creating a subtle but measurable oscillation in the geometry of space itself. When these ancient ripples finally reach Earth, they are incredibly faint, stretching and compressing distances by amounts smaller than 1,000th of the width of a proton. Yet human ingenuity has created instruments sensitive enough to detect these whispers from the cosmic deep. The LIGO detectors with their 4-kilometre-long arms can measure changes in length so small that they would be dwarfed by the width of an atomic nucleus. But gravitational waves are not just exotic phenomena created by colliding black holes. They are a fundamental aspect of how the universe communicates with itself. Every accelerating mass creates these ripples, though most are far too weak to detect with current technology. The Earth orbiting the Sun creates gravitational waves. Your heart beating creates gravitational waves. Even the gentle rise and fall of your breathing sends tiny ripples through the fabric of space-time. As you rest here, you are both creating and experiencing these cosmic ripples. Your body, composed of matter that curbs space-time around it, is constantly generating its own gravitational field and the supple waves that accompany any change in that field. When you shift position, when your heart beats, when you breathe, you are composing a gravitational symphony that propagates outward at the speed of matter and energy that fills the universe. The beauty of gravitational waves lies not just in their existence, but in what they reveal about the nature of reality itself. Unlike light, which can be absorbed, scattered, or blocked by matter, gravitational waves pass through everything unchanged. They carry information about the most extreme environments in the universe, the hearts of colliding black holes, the cores of neutron stars, perhaps even the primordial moments of the Big Bang itself. These waves also represent a new form of astronomy, a way of sensing the universe that complements our traditional reliance on electromagnetic radiation. Where light shows us the surfaces of stars and the glow of hot gas, gravitational waves reveal the dynamics of space-time itself. They allow us to hear the universe in an entirely different way, to detect cosmic events that produce no light at all. The detection of gravitational waves has opened our senses to cosmic phenomena that were previously invisible. Binary neutron star collisions, detected both through their gravitational waves and the light they produce, have shown us the cosmic forges, where heavy elements like gold and platinum are created. The ripples in space-time arrive first, followed seconds later by the gamma-ray burst and the gradually fading optical afterglow. But perhaps the most profound aspect of gravitational waves is what they tell us about the universe's most ancient history. The cosmic microwave background radiation shows us the universe as it was nearly 14 billion years ago, when it first became transparent to light. But gravitational waves can travel from even earlier epochs, potentially carrying information about the universe's inflationary period, about the moment when space-time itself was expanding faster than light. These primordial gravitational waves, if they exist and can be detected, would be the oldest possible signal from the cosmos, ripples in the fabric of reality that originated in the first moments of existence itself. They would carry information about the quantum nature of space-time, about the fundamental forces that shape the universe's initial conditions, about the very mechanism that created the cosmos as we know it. As you contemplate these waves rippling through space-time, you begin to understand that you are not separate from the cosmic web of gravity and matter that surrounds you. Your gravitational field, however small, is part of the same fundamental force that holds galaxies together, that guides the motions of planets, that created the conditions of stars to form and life to emerge. The ripples you create through your existence, the gravitational waves generated by your movement, your breathing, your heartbeat, are travelling outward through the universe right now, carrying information about this moment to distant corners of the cosmos. In some unimaginably remote future, these waves will pass through regions of space that are currently empty, perhaps to be detected by forms of intelligence that have not yet evolved. This creates a beautiful reciprocity in the universe's communication system. Just as you are constantly receiving gravitational waves from cosmic events throughout the universe, your body slightly stretched and compressed by the passage of these space-time ripples, you are also constantly sending your own gravitational signature outward, participating in the cosmic conversation that connects all matter and energy across space and time. The study of gravitational waves has also revealed something profound about the nature of extreme matter. When neutron stars collide, they create conditions of density and temperature that cannot be replicated in any laboratory. The gravitational waves from these collisions carry information about how matter behaves under these extreme conditions, about the fundamental properties of atomic nuclei pushed to their limits. These cosmic laboratories also demonstrate the elegant interplay between Einstein's theory of general relativity and quantum mechanics. The neutron stars themselves are quantum objects, their matter held up against gravitational collapse by the quantum mechanical exclusion principle. Yet their collision is perfectly described by Einstein's classical theory of curved space-time. As you rest here, surrounded by these invisible ripples in the fabric of reality, you might begin to sense the dynamic nature of the universe itself. Space-time is not a passive stage, but an active participant in cosmic evolution, responding to the presence of matter and energy, carrying information across vast distances, connecting every part of the universe to every other part through the fundamental language of gravity. The gravitational waves washing over you right now carry stories from across the cosmos, tales of stellar death and birth, of the violent mergers that forge heavy elements, of the cosmic processes that created the conditions for your existence. And in turn, your own gravitational waves are writing new chapters in this cosmic story, adding your voice to the symphony of space-time that has been playing since the universe began. But as you feel these ripples in the fabric of reality, you might find yourself wondering about the very nature of time itself, how it flows, how it connects to space, and whether our experience of its passage reflects some deeper truth about the structure of existence. Imagine time as a river that once flowed in all directions at once, or perhaps didn't flow at all. In the very beginning, in those first moments after the Big Bang, the universe existed in a state so simple and symmetrical that the distinction between past and future had not yet been born. Time was there, woven into the fabric of space-time itself, but it had not yet learned to point in any particular direction. You are resting now in the dome stream of that cosmic river, carried along by the current of time's arrow toward an unknown future. Every breath you take, every heartbeat, every gentle shift in your position represents another moment in time's forward journey, a journey that began when the universe first discovered the difference between what was and what could be. The mystery of time's arrow is one of the deepest puzzles in all of physics. Most of the fundamental laws of nature work equally well, whether time flows forward or backward. The equations that describe how particles interact, how forces propagate, how energy transforms from one form to another, All of these remain mathematically valid if you reverse the direction of time. Yet your direct experience tells you that time has a clear direction. Causes precede effects, eggs can be broken but not unbroken, and memories point toward the past while hopes reach toward the future. This arrow of time emerges from something deceptively simple: the universe's journey from order to disorder, from simplicity to complexity, from the perfectly smooth conditions of the early cosmos to the wonderfully messy, structured, life-bearing universe you inhabit today. This journey is governed by the second law of thermodynamics, which states that entropy, the measure of disorder in a system, always increases over time. But here lies the beautiful paradox. If entropy always increases, why did the universe begin in such an extraordinarily ordered state? The Big Bang did not start with maximum entropy, as you might expect from a random explosion. Instead, it began with matter and energy distributed almost perfectly uniformly, with only the tiniest of quantum fluctuations disturbing the cosmic smoothness. This initial state was incredibly improbable, incredibly ordered, and it is this special beginning that gives time its arrow. Picture the early universe as a vast, smooth lake, at the moment just after the first stone has been thrown into its center. The ripples are just beginning to spread outward, carrying energy and information across the previously undisturbed surface. As these ripples interact and interfere with each other, they create increasingly complex patterns. This is how the universe learned to complexify. The smooth, hot plasma of the early cosmos began to cool and condense, forming the first atoms, then the first stars, then the first galaxies. Each step in this cosmic evolution increased the universe's entropy, while simultaneously creating new forms of order and structure. Stars formed from gravitational collapse, but they also created the heavy elements necessary for planets and life. Galaxies organized themselves into vast cosmic webs, but they also created the conditions for stellar nurseries and planetary systems. The arrow of time is intimately connected to this process of structure formation. As the universe expanded and cooled, it opened up new possibilities for organization. The first stars could not have formed in the hot, dense conditions of the early universe. Life could not have evolved without the heavy elements forged in stellar cores. Consciousness could not have emerged without the complex chemistry that requires billions of years of cosmic evolution. You are living proof of time's arrow, a being whose very existence depends on the universe's long journey from simplicity to complexity. The carbon in your body was forged in the heart of a dying star. The oxygen you breathe was created in stellar fusion reactions. The iron in your blood was scattered into space by a supernova explosion. Your existence is possible only because time has an arrow, because the universe has been able to evolve from its simple beginnings into something capable of creating and sustaining life. But the arrow of time is not just about the universe's large-scale evolution. It's also present in the most intimate details of your daily experience. When you remember something, you are accessing information that was stored in your brain at some point in the past. When you make a decision, you are using current information to influence future outcomes. When you feel the warmth of sunlight on your skin, you are experiencing energy that left the sun's surface 8 minutes ago, carrying the arrow of time from one location to another. The psychological arrow of time, your sense of moving from past to present toward future, appears to be deeply connected to the physical arrow of time in the universe around you. Your memories form because your brain is a complex system that can store information about past states, and this storage process increases entropy in accordance with the second law of thermodynamics. Your ability to plan for the future depends on the causal structure of space-time, where causes precede effects and information propagates at finite speeds. Even your consciousness seems to participate in time's arrow. The stream of your thoughts flows in one direction, from one moment to the next, creating the narrative thread that connects your past self to your future self. This subjective experience of temporal flow might be an emergent property of complex information processing systems like your brain, systems that can only exist in a universe where time has a clear direction. The arrow of time also reveals something profound about the nature of possibility and actuality. In the early universe, many different futures were possible. The quantum fluctuations that seeded structure formation could have evolved in countless different ways. But as time flowed forward, these possibilities gradually crystallized into actualities. The universe chose one path among many, and this choice was irreversible. The stars that formed, the galaxies that coalesced, the planets that emerged, all of these represent paths taken that closed off other possibilities. Rest here in this moment and imagine the space around you, not just the air between your body and the walls, but the fundamental fabric of reality itself. What you might think of as empty space is actually alive with invisible activity, humming with an energy so subtle and profound that it shapes the very nature of existence. This is the quantum vacuum, and it is singing a lullaby that has been playing since the universe began. In the classical world of everyday experience, empty space seems like nothing at all, a void waiting to be filled. But quantum mechanics reveals that even the most perfect vacuum, stripped of every particle and every photon, still seethes with activity. Virtual particles appear and disappear in the span of time so briefly that they seem to violate the conservation of energy, borrowing from the universe's quantum bank account. These quantum fluctuations are not just mathematical curiosities, but fundamental features of the fabric of space-time itself. They represent the universe's way of exploring every possible configuration of matter and energy, even in regions where no matter or energy appears to exist. The vacuum is not empty, full of potential, full of possibility, full of the ghost-like presence of every particle that could exist. Picture the quantum vacuum as a vast ocean of possibility, its surface appearing calm and empty from a distance, but alive with countless. These fluctuations are the universe's way of dreaming about what could be, and occasionally, under the right conditions, these dreams become reality. Virtual particles can become real particles, quantum possibilities can crystallize into actual events, and the vacuum's hidden energy can manifest as the matter and forces that shape the physical world. You are resting now in a space that is far from empty. Even in the regions between your atoms, even in the vast spaces between the electrons and the nuclei that make up your body, the quantum vacuum is active. Its fluctuations influence the behavior of the particles that constitute you, contributing to the forces that hold atoms together, the fields that enable chemical reactions, and the subtle quantum effects that make your existence possible. The vacuum's hidden energy has a profound effect on the fundamental forces of nature. The electromagnetic force, which governs the interactions between charged particles, is mediated by virtual photons that constantly appear and disappear in the quantum vacuum. These virtual particles are the universe's way of transmitting force across space, creating the connections between distant charges and currents that make electricity, magnetism, and light possible. Even the mass of fundamental particles is influenced by the vacuum's activity. The Higgs field, which permeates all of space and gives particles their mass, is intimately connected to the quantum vacuum. When particles interact with this field, they acquire the property we call mass, and this interaction is mediated by the vacuum's fluctuations. In a very real sense, the vacuum is responsible for the weight of the world, for the mass of every atom in your body, for the substance that makes you real. The vacuum's symphony also plays a crucial role in the stability of matter itself. The quantum fluctuations create what physicists call zero-point energy, the lowest possible energy state that any quantum system can have. This energy cannot be removed or harnessed, but it influences the behavior of particles and fields in subtle but important ways. It contributes to the pressure that prevents atoms from collapsing, helps determine the properties of materials, and influences the rate at which radioactive nuclei decay. The bonds between atoms, the angles at which they connect, the energy required to break them apart, all of these properties are influenced by the quantum vacuum's fluctuations. The vacuum is not just the stage upon which chemistry unfolds, but an active participant in the molecular dance that sustains life. The vacuum's hidden symphony extends far beyond the realm of particles and forces. It may have played a fundamental role in the birth of the universe itself. During the epoch of cosmic inflation, the quantum fluctuations of the vacuum were stretched to macroscopic scales, becoming the seeds of the large-scale structure we observe today. The galaxies, stars, and planets that fill the cosmos all trace their origins to quantum fluctuations that once existed only in the vacuum's hidden realm. These vacuum fluctuations also contribute to one of the most mysterious phenomena in modern physics, the accelerating expansion of the universe. Dark energy, the force that appears to be driving the cosmos apart at an ever-increasing rate, might be related to the energy density of the quantum vacuum. If so, then the vacuum's hidden symphony is not just playing in the spaces between particles, but is actually determining the ultimate fate of the universe itself. The vacuum's activity also manifests in phenomena that seem to violate our everyday understanding of energy conservation. The Casimir effect, where two metal plates in a vacuum are pushed together by the vacuum's fluctuations, demonstrates that empty space can exert real, measurable forces. The vacuum between the plates has fewer possible quantum states than the vacuum outside, creating a pressure difference that results in an attractive force. This effect has been measured in laboratories and is now used in some micromechanical devices. The virtual particles from the vacuum can also become real under extreme conditions, near the event horizon of a black hole. The vacuum's fluctuations can be separated by the intense gravitational field, with one member of a virtual particle pair falling into the black hole while the other escapes as real radiation. This Hawking radiation represents the vacuum's energy being converted into actual particles, causing black holes to slowly evaporate over time. The vacuum symphony also influences the behavior of light. When photons travel through regions of strong electromagnetic fields, they can interact with the virtual particles in the vacuum, causing subtle changes in their properties. This vacuum polarization affects the propagation of light and contributes to the slight deviations from perfect electromagnetic behavior that have been observed in precision experiments. Even the concept of nothingness becomes problematic in the context of the quantum vacuum. What we call empty space is actually filled with quantum fields in their lowest energy states, still fluctuating, still active, still contributing to the fabric of reality. True nothingness, the complete absence of fields, fluctuations, and possibilities, appears to be impossible in our universe. The vacuum is as much a part of reality as the particles and forces we can directly observe. As you rest here, you are immersed in this quantum symphony, surrounded by the vacuum's gentle but persistent activity. The forces that hold your atoms together, the fields that enable your neural activity, the fundamental interactions that make consciousness possible, all of these are influenced by the vacuum's hidden energy. You are not separate from this quantum realm, but intimately connected to it, a complex pattern of matter and energy that emerges from and depends upon the vacuum's fluctuations. The vacuum's symphony also raises profound questions about the nature of existence itself. If empty space is not truly empty, if the vacuum is filled with activity and potential, then what does this tell us about the fundamental nature of reality? Are the particles and forces we observe merely temporary disturbances in a more fundamental quantum field? Is what we call matter simply a particular pattern of vacuum fluctuations, like waves on an ocean that appear solid but are really just organized movements of water? These questions point towards some of the deepest mysteries in physics. The relationship between quantum mechanics and gravity, the nature of space and time at the smallest scales, and the possibility that everything we observe might emerge from more fundamental quantum processes. The vacuum's hidden symphony might be the universe's way of exploring these fundamental questions, using its fluctuations to probe the deepest levels of reality. As you drift towards sleep, carried by the gentle rhythms of your breath and heartbeat, you might begin to sense you float now in a contemplation that has puzzled minds for centuries. The profound coincidence of your existence. Tonight, as you rest between waking and sleeping, consider how the universe seems to have been crafted with extraordinary precision, as if every fundamental constant, every physical law, every cosmic parameter was adjusted with infinite care to allow you to lie here, wondering. The constants of physics dance together in perfect harmony. If the electromagnetic force was slightly stronger, atoms could never hold together long enough to form the complex molecules that flow through your blood. If gravity were just a whisper more powerful, stars would burn out in millions of years instead of billions, never giving evolution the vast stretches of time needed to craft consciousness from simple chemistry. If the nuclear forces binding protons and neutrons were adjusted by mere percentages, the hearts of stars could never forge the carbon, oxygen and iron that compose your body. This delicate balance extends to the very fabric of space-time itself. The cosmological constant, that mysterious energy woven into empty space, sits at a value so precisely tuned that if it were larger by even 1 part in 10 to the power of 120, the universe would have expanded too rapidly for galaxies to form. 1 part in 10 to the power of 120. Imagine trying to hit a target the size of a coin, not just somewhere on Earth, but somewhere in a volume of space containing 10 to the power of 120 universes like ours. This is the precision with which reality appears to be calibrated. You breathe in, and oxygen molecules find their way to your cells through a cascade of chemical reactions that depend on electron orbitals shaped by quantum mechanics. The electrons themselves exist in states determined by Planck's constant, a number that, if different by small amounts, would make chemistry impossible. The photons streaming from your bedside lamp carry energy in discrete packets, their wavelength determined by the speed of light, another constant that seems chosen to make your world possible. Even the expansion rate of the early universe appears fine-tuned. In the first moments after the Big Bang, if expansion had been slightly faster, matter would have spread too thin for gravity to gather it into the clumps that became galaxies and stars. If expansion had been slightly slower, the universe would have collapsed back into itself before stars could ignite. The rate was set with extraordinary precision, allowing cosmic evolution to unfold over billions of years, giving time for simple hydrogen to transform into the complex chemistry of life. Your existence depends on the curious fact that the universe began with tiny fluctuations in density. Quantum ripples stretched to cosmic scales by inflation. These ripples were neither too large nor too small. If they had been weaker, the universe would have remained forever smooth and empty. If they had been stronger, it would have immediately collapsed into black holes. Instead, they were just right, creating the scaffolding on which galaxies, stars, planets, and you were built. The ratio of matter to antimatter in the early universe reveals another precise adjustment. For every billion pairs of particles and antiparticles, there was 1 extra particle of matter. This tiny asymmetry, 1 part in a billion, ensured that when matter and antimatter annihilated each other, enough matter remained to form everything you see. A slightly smaller asymmetry would have left the universe nearly empty. A larger one might have created conditions too violent for stars to form. Even the properties of water seem remarkably suited to life. Unlike most substances, water becomes less dense when it freezes, allowing ice to float and insulate the liquid below. Its specific heat capacity helps moderate temperature changes. Its ability to dissolve so many substances makes it the perfect medium for the chemical conversations that sustain your cells. The angle of hydrogen bonds in water molecules, determined by fundamental physics, creates these life-enabling properties. The carbon atom itself appears designed for complexity. With 6 protons and 6 electrons, carbon can form 4 bonds, creating the branching, linking 3-dimensional structures that make proteins and DNA possible. Silicon, the next element down in the periodic table, might seem like an alternative, but its bonds are too weak to maintain the intricate molecular machines that power your thoughts and dreams. Only carbon, with its precise nuclear configuration, can serve as the foundation for the chemistry of consciousness. Your position in the galaxy reflects another layer of cosmic fine-tuning. Too close to the galaxy center, and radiation from the central black hole would sterilize any planet. Too far out, and there wouldn't be enough heavy elements to form rocky worlds. Earth orbits in the galactic habitable zone, where conditions allow for the stable long-term evolution of complex life. The Sun itself is a Goldilocks star, not too hot, not too cool, but just right for warming a planet at the right distance for liquid water. More massive stars burn too quickly and die too young. Less massive stars produce too little energy and subject their planets to harmful radiation. The Sun's mass, determined by the cloud of gas and dust from which it formed, falls in the narrow range that allows for billions of years of stable energy output. Some propose that we observe these fine-tuned conditions simply because we must, that in a universe not suited for life, there would be no observers to notice the unsuitability. This is the anthropic principle. The universe appears fine-tuned for life because only in a universe capable of producing life would there be beings capable of asking the question. It's a circular logic that dissolves the mystery by making it a requirement of observation itself. Others suggest that ours is just one universe among infinite others, each with different physical constants, different laws, different possibilities. We find ourselves in one of these rare, life-permitting universes not because it was designed for us, but because it's the only kind of universe where we could exist to wonder about our existence. Yet as you contemplate these possibilities, a deeper mystery emerges. Whether the fine-tuning is the result of design, selection, or pure chance, it points to something profound about the nature of reality itself. Some propose that we observe these fine-tuned conditions simply because we must. That in a universe not suited for life, there would be no observers to notice the unsuitability. This is the anthropic principle. The universe appears fine-tuned for life because only in a universe capable of producing life would there be beings capable of asking the question. It's a circular logic that dissolves the mystery by making it a requirement of observation itself. Others suggest that ours is just one universe among infinite others, each with different physical constants, different laws, different possibilities. We find ourselves in one of these rare, life-permitting universes not because it was designed for us, but because it's the only kind of universe where we could exist to wonder about our existence. Yet as you contemplate these possibilities, a deeper mystery emerges. Whether the fine-tuning is the result of design, selection, or pure chance, it points to something profound about the nature of reality itself. You rest now in the quiet space between breaths, and in this gentle pause consider that the universe itself might be breathing, expanding and contracting in cycles so vast that our entire cosmic history is but a single inhalation and an eternal rhythm. Tonight, as you prepare for sleep, let your mind wander through the possibility that what we call the beginning might simply be another moment in a story that has no true start or end. The Big Bang, that magnificent explosion of space and time that birthed our cosmos, may not have been the first. Deep in the mathematics of cosmology, scientists have discovered equations that suggest our universe could be part of an infinite cycle, a cosmic heartbeat that has been pulsing for eternity. Each expansion followed by contraction, each birth followed by death, each death followed by rebirth. Imagine the cosmos as a vast lung, breathing in and out across trillions of years. Right now, in this moment as you lie in bed, you exist during the expansion phase, the long, slow exhalation that began 13.8 billion years ago and continues still. Galaxies drift apart like exhaled breath dispersing in cold air. Stars burn and die. The universe grows cooler, darker, more dilute with each passing eon. But perhaps this expansion will not continue forever. Deep in the heart of cosmic physics lies a possibility that sends shivers through the imagination. The Big Crunch. Just as a thrown ball must eventually fall back to Earth, the universe might one day slow its expansion, pause in a moment of perfect stillness, and then begin. The galaxies would start moving toward each other instead of away. The cosmic background radiation would begin to heat up rather than cool down. The universe would begin to breathe in. Their contraction would unfold like expansion in reverse, but with profound differences. As galaxies drew closer together, the night sky would gradually brighten. Stars would form more rapidly as gas clouds collided and merged. The universe would become denser, hotter, more energetic. Eventually all the matter and energy that now fills billions of light years of space would compress back into a volume smaller than an atom. In the final moments before the Big Crunch, temperatures would soar beyond imagination. The cosmic background radiation would grow so hot that it would tear apart every atom in existence. Protons and neutrons would dissolve into their constituent quarks. The fundamental forces of nature would merge back into a single, unified field. Space and time themselves would begin to break down as the universe approached what cosmologists call a singularity, a point of infinite density where the laws of physics as we know them cease to apply. But here's where the story becomes even more extraordinary. Some theories suggest that this apparent end might actually be a beginning. The Big Crunch could trigger another Big Bang. Like a cosmic phoenix rising from its own ashes, the singularity might not be a point of destruction, but a moment of transformation. A cosmic reset that launches a new cycle of expansion and evolution. In this cyclic model, universes are born, grow old, and die, only to be reborn again in slightly different forms. Each cycle might last hundreds of billions of years, with periods of expansion and contraction stretching across timescales that dwarf human comprehension. The universe that emerges from each rebirth might have slightly different physical constants, different laws of nature, different possibilities for the evolution of complexity and consciousness. Consider the profound implications of this eternal return. Every atom in your body, every thought in your mind, every moment of your existence might have occurred countless times before in previous cycles. The carbon in your cells, forged in the hearts of ancient stars, might have been forged and reforged in the hearts of stars that burned in universes that existed before our own. The patterns of synapses firing in your brain as you contemplate these words might be echoes of thoughts that have been thought in countless previous incarnations of cosmic evolution. Yet each cycle would not be an exact repetition. Quantum mechanics, with its inherent uncertainty, would ensure that each universal rebirth would unfold slightly differently. The positions of particles, the timing of stellar births, the pathways of evolution, all would vary from cycle to cycle. Some universes might never develop galaxies, others might be filled with forms of life unimaginable to us. Each cosmic breathing cycle would be a unique experiment in the possibilities of existence. The ancient philosophers spoke of eternal return as a fundamental principle of reality. The Stoics believed that the universe periodically consumed itself in cosmic fire, only to be reborn exactly as it was before. Hindu and Buddhist traditions speak of endless cycles of creation and destruction, with each cycle lasting billions of years. These ancient intuitions, born from contemplation rather than calculation, might have glimpsed a deep truth about the nature of time and existence. Modern physics has given new precision to these ancient ideas. The equations of general relativity, Einstein's description of space and time, allow for universes that expand and contract in eternal cycles. String theory, which attempts to unify quantum mechanics and gravity, suggests that our universe might be one of many brains floating in a higher dimensional space, occasionally colliding to create new Big Bangs. The concept of eternal return also emerges from thermodynamics, the study of heat and energy. In a closed system, entropy always increases, leading to what physicists call heat death, a state where energy is evenly distributed and no further work can be done. But some theories suggest that even heat death might not be final. Quantum fluctuations, the random appearances of particles from empty space, might eventually create new regions of low entropy, sparking fresh cycles of cosmic evolution. As you breathe in and out, your own body demonstrates the principle of cyclic return on a smaller scale. The oxygen you inhale was once part of ancient oceans, then part of plants, then part of the atmosphere, and now part of you. After you exhale, those same atoms will continue their journey, becoming part of other living beings, other processes, other stories. Your very existence participates in cycles within cycles within cycles. The water in your cells has been cycling through the Earth's hydrological system for billions of years. It has been rain and snow, rivers and oceans, clouds and ice. It has been part of dinosaurs and bacteria, forests and mountains. Now it flows through your bloodstream, carrying nutrients and messages, participating in the chemistry of consciousness, before returning to the great cycle of planetary water. Even the atoms that compose your body are temporary guests. Every 7 to 10 years, most of the matter in your body is replaced through the normal processes of living. You are not a fixed thing, but a pattern, a temporary arrangement of atoms that have been part of countless other patterns before you, and will be part of countless other patterns after you. You are a wave in an ocean of matter and energy that has been flowing for eternity. The idea of eternal return might seem to diminish the importance of individual existence. If everything repeats, does anything matter? But perhaps it suggests the opposite. If this moment, this breath, this thought, or this feeling of wonder as you contemplate the cosmos, if all of this is part of an eternal cycle, then it participates in cyclic cosmology. Time becomes not a straight line from past to future, but a spiral, always moving forward, but also always returning. Each cycle builds upon the last, creating new possibilities while echoing ancient patterns. The future becomes not just what happens next, but what might happen again, differently, beautifully, surprisingly. As you settle into sleep, you become part of your own small cycle, the daily rhythm of waking and sleeping that mirrors the cosmic breathing of expansion and contraction. Your dreams tonight might carry echoes of dreams dreamed in other cycles, other times, other versions of yourself in other versions of the universe. And tomorrow when you wake, you participate in another small rebirth, another turn in the endless spiral of becoming. Perhaps consciousness itself is the universe's way of remembering its own eternal return, a way for the cosmos to recognize its own face in the mirror of awareness, to know that it has been here before and will be here again. You lie here in the darkness, contemplating the universe, and in this very moment of contemplation, you embody one of the deepest mysteries in all of science. The simple act of wondering about the cosmos makes you an integral part of the story you're trying to understand. You are not just observing the universe, you are the universe observing itself. This is the observer's paradox. The moment you try to step outside the cosmic narrative to examine it objectively, you realize you cannot escape it. You are made of the same atoms forged in stellar cores, governed by the same physical laws, shaped by the same evolutionary processes that you seek to comprehend. The carbon in your neurons, the oxygen in your blood, the calcium in your bones, all are characters in the cosmic drama, and through them, the universe has developed the capacity to wonder about its own existence. Consider how strange this is. For billions of years, the universe evolved without consciousness, at least as far as we know. Stars burned, planets formed, chemical reactions unfolded in perfect accordance with physical laws, but there was no awareness to witness these processes. Then, through a series of events still not fully understood at matter, organized itself into patterns complex enough to generate inner experience. The universe opened its eyes and began to see itself. You represent an extraordinary phase transition in cosmic evolution. Through your consciousness, the universe has developed not just the ability to observe itself, but to question its own nature. Every scientific discovery, every moment of wonder, every philosophical insight emerges from this cosmic self-awareness. When you marvel at the intricate dance of subatomic particles, you are those particles marveling at their own behavior. The observer's paradox runs deeper than mere philosophy. In quantum mechanics, the act of observation fundamentally changes what is being observed. Before measurement, particles exist in states of superposition, simultaneously occupying multiple possibilities. The moment you observe them, they collapse into definite states. This suggests that consciousness and physical reality are intertwined in ways that challenge our intuitive understanding of objectivity. As you breathe in the quiet darkness, you participate in an ancient cycle that connects you to the first moments of cosmic history. The oxygen filling your lungs was forged in the nuclear furnaces of dying stars. The water in your cells has been cycling through Earth's systems for billions of years. You are not separate from the universe you're contemplating. You are a temporary arrangement of its matter and energy, briefly organized into a pattern capable of self-reflection. This realization dissolves the artificial boundary between observer and observed. You are not a detached spectator, watching the cosmic story unfold from some imaginary vantage point outside reality. You are a protagonist in the narrative, a conscious node in the web of existence through which the universe comes to know itself. Your thoughts about the cosmos are the cosmos thinking about itself through the medium of your mind. Tonight, as you drift towards sleep, you carry with you this profound recognition. In wondering about the universe, you complete a circle that began with the Big Bang itself, and perhaps prepare the way for an even deeper mystery, the question of what dreams might emerge when the cosmos finally learns to sleep. You rest now at the edge of sleep, and in this gentle transition, you embody the universe's most beautiful patter, recursion. Like a spiral shell growing from its own center, reality unfolds through endless loops of renewal, each ending becoming the beginning of something new. Your breath slows, your thoughts soften, and you participate in a cosmic rhythm that has been pulsing since the first moment of existence. The recursion runs deeper than cycles. It's the way each generation of stars creates the elements for the next. How consciousness emerges from matter, only to contemplate the matter from which it came. How questions about existence lead to new questions about the questioner. You are part of this infinite loop stardust that learn to wonder about stars, atoms that achieve the ability to ponder atoms, a temporary pattern in the cosmic web that has developed the capacity to recognize its own temporary nature. Tonight, as you surrender to sleep, you complete another turn in the gentle recursion of awareness. Your dreams will weave new patterns from the day's experiences, just as evolution weaves new forms from ancient templates. And tomorrow, when you wake, you will carry forward something subtly transformed, perhaps a new understanding of your place in the vast recursive dance of becoming. You settle into sleep's embrace, and in this moment of surrender, you rest in the cosmic cradle that has been rocking since time began. The same fundamental forces that ignited the first stars now pulse gently through your dreams. Gravity holds you to Earth as tenderly as it holds planets in their orbits. The electromagnetic force that binds atoms together courses through your neural pathways, carrying thoughts and dreams like whispered lullabies. You are cradled by space-time itself, wrapped in the fabric of reality that curves around every particle of your being. The universe doesn't just contain you, it embraces you, supports you, nurtures you with the same care it has shown every galaxy, every star, every grain of cosmic dust. You float in an ocean of dark energy that gently accelerates the expansion of space, carried forward on currents older than memory. Even in sleep, you remain connected to the cosmic web, that vast network of matter and energy that links every corner of existence. Your dreams tonight will unfold within this infinite embrace, held safe by forces that have been protecting and guiding the universe's story for billions of years. And perhaps, in the deepest rest, you will sense something even more profound, the universe's own quiet dreams of what it might become.